Okay guys, I'm going to skip number 3 for the video because just like in class, I sometimes overestimate or underestimate the amount of time it's going to take for me to get through these problems. So I'm leaving this as an extra example for you to do if you so choose to test yourself on deciding whether you need the future or present annuity formula, and I'm giving you the final answer there to check your work. So feel free to do that, and if you have any questions, you can email me or message me in Canvas about that. But we're going to go ahead and move on to the idea of sinking funds. Now, your program doesn't specifically refer to these as sinking funds, but this is the technical name for it. So this is when there is a fund of money that is being accumulated to meet some future expense. So we've sort of already seen that in our example where the grandparents were putting money into an account to meet this future expense of their granddaughter's college. Okay, so this is the same idea. What a sinking fund really is that future value annuity formula that we already know solved for R. That's the only difference. So future value annuity and sinking funds are really the same thing. It just so happens that in the sinking fund situation, this is when we already have, sorry, I lost my place in my notes here, just a second. So this is when we already have, or when we don't have the big R, the periodic payment amount, but instead we're trying to find that big R amount. In this case, we must have that future value amount or that S amount. And be really careful when you're solving these that you put that entire denominator in parentheses in your calculator if you're using this format of the formula. Okay, so how does this work? So the question could be phrased in a way like this. What amount should be deposited at the end of each month into for 3 years in a savings account earning 4.5% interest compounded monthly in order to accumulate $18,000 to buy a car? So a sinking fund is basically when, again, you're planning ahead for some future expense and you're thinking, okay, well, I'm going to start putting money in this savings account so I will, in 3 years, I want to have enough money to buy this car. How much should I deposit at the end of every month? So since we're looking for the to be deposited, we know we're looking for this big R. We know that we're going to do this at the end of each month. So our M is 12 for 3 years, so T is 3. Our rate is 0.045. Compounded monthly is just reiterating that this is happening every month. And we are hoping to accumulate $18,000, so that's our big S. So again, if you want to, you can go grab that future value and you can solve it for R, but I just think it's easier to use a formula that's already solved for R. So I'm going to set this up, big R equals, and then set up a giant fraction. First we have to do little r over m, so 0.045 over 12 in this case, times that accumulated amount, so times $18,000, divided by, in brackets, huge brackets, and then a set of parentheses, 1 plus 0.045 over 12, close those parentheses, to the 12 times 3 power, and then down again on the main level, minus a 1, close your brackets. Okay, so these can get even a little more hairy to get in your calculator correctly. That's why I always ask for this much for partial credit, so that I can tell, did you use the right formula? Check, that's worth some credit to me. Did you put all the values in where they go? Check, that's worth some credit for me. And then, did you get it in your calculator correct? That's kind of the last step of credit for me. And, you know, if you type it in there incorrectly, I don't want you to lose all of your points for that. So let's go ahead and start this. We want to do 0.045 over 12 and multiply that by 18,000. That came out really nice, so I'm going to record that on the top. Just again, if I have something to go back to, if I needed to rework this problem. Now, I'm going to do all of this next part though, because I don't want to figure out the denominator separately and then try to divide later by something that I've maybe rounded off. Because if you round off anywhere in this work, you can get off by quite a lot by the end. So I'm going to say divided by, I need an opening parenthesis for the bracket, and then I need an immediate second parenthesis for this parenthesis set that has 1 plus 0.045 over 12 in it. Close up that inner parenthesis to the 12 times 3 is 36, so I'm going to make my life a little bit easier there. Back down to the main level, we want to do a -1, and then close that up with one more set of parentheses. So I've got in parentheses inside of parentheses, but this looks good. I'm dividing that 67.5 by all of this, and I get $467.94. So they're going to deposit that much at the end of every month for 3 years, and they're supposed to accumulate $18,000. Okay, so that's the periodic payment amount. Now, these follow-up questions, or again, if you're asked for anything else other than the future value, present value, or now the big R, the periodic payment, then you probably need like multiplication, division, subtraction, something like that. So how much do you actually deposit? Well, you deposit $467.94 every month, so times 12 for 3 years, so times 3. So you multiply all three of those values together. So let's see, 467.94 times 12 times 3. So you deposit $16,845.84. How much interest do you make? Well, remember, you eventually had $18,000 to buy this car. So you eventually had $18,000. Subtract off the $16,845.84. And if you do that subtraction, you should get, let's see, $1,154.16. So by planning ahead, you just save yourself basically about that much money. That $1,154.16 is money that you earned that you didn't have to come up with on your own. So some notes. Again, some texts do not distinguish between that sinking fund and that future value annuity because they are the same formula, just solve for a different variable. So again, I don't care what your preference is. Use whichever version you want. I'm showing you my preference because I do feel like it's a little bit easier, but it doesn't really in the end matter to me what formula you use. You can technically use either. Okay, so what you would want to do now is choose the easier formula to use below to solve and then solve.